Hi, my name is Sunny Rajagopalan. I work for PlumGrid, and I'm going to use this session today to talk about federation. Now, there have been quite a few talks in OpenStack about federation, about different aspects of federation, and I'm going to use this opportunity to talk about the use cases that we've seen are really what customers have in mind with the people that we talk to, and the ones that we're building our solution around. So that's just the introduction, what I spoke about. And to be clear, this is not just about Keystone Federation or even about just federation of OpenStack clouds. We are talking about something which is slightly broader in scope than just those two limited use cases, which we'll talk about. So the first use case of federation that we've seen and that people come to us about is for hybrid clouds. And this is a very broad definition of hybrid clouds. We're not just talking about public and private clouds. For example, connecting your own private OpenStack cloud with AWS or Azure. We're not just talking about that. We're talking about maybe combining your private cloud with, let's say, your bare metal cloud, which is connected to the outside world using a Cisco router. So how do you connect these two together, and how do you orchestrate these things? It's not just OpenStack all the way. So here's another reason that people think about federation. It's for component redundancy, and this picture gives you an example of what that means. If you've got a load balancer, and if you've got two clusters of different flavors, and I mean from what I said earlier, these clusters don't even have to be both OpenStack. So if you may have that load balancer front end, some services which are present in one cluster and some services which are present in another cluster. So you need a way to kind of seamlessly connect these clusters to make topologies like this work. So here's another reason that you need federation. Scaling. Now I mean, a lot of people are working on scaling OpenStack, and that's a really good thing to do. You should definitely try to scale Nova and Neutron and your RabbitMQ. But the thing is that even if you could get OpenStack to scale to thousands of nodes, the question is, even if you could, should you? You know, just because you may want to keep your failure domains or blast radius more contained. So just for that reason, maybe it makes sense to keep your OpenStack cluster contained to today maybe 100 nodes, and then use federation to scale out. So you wouldn't put all your VMs in one cluster. In this case, you would put it in different clusters, and you need to pair these two clusters together. More reasons for doing federation. Now, if you've connected these two clusters together, what we've seen is that a lot of times customers will want to do sort of rolling upgrades of their OpenStack clusters. So they may have one cluster running the latest and greatest, and then another cluster which is running just a slightly older version. And at some point, let's say Liberty is released, and they want to do. They want to upgrade one cluster. They want to do a +1 of the version that each cluster is running. And if these clusters are interconnected together, and this is your own little private virtual network, which you've combined in these two clusters. So this lets you do non-disruptive upgrades, because you can transition your VMs out of one cluster into another cluster, and all the while you're doing live migration, you still have connectivity with everybody in your in your mega cluster. And once you've done a migration of your VMs, you can upgrade your cluster. It doesn't matter even if you have outage, because your VMs are no longer inside that cluster. And once your upgrade is over, you can migrate your VMs back in and then upgrade the next cluster. So it's useful for that. Here's another interesting use case for federation. What you might want to do is provide a global service which spans maybe multiple geographical regions, and the way a lot of people do this is to have one zone which is maybe running a GSLB. GSLB, for those of you who are not familiar with it, is a load balancer / DNS server. It responds to DNS queries usually based on where the client is located. So it's more likely to give you, like if you had more than one IP address which you could resolve your DNS query to, it'll give you the one that's closer to where the client is located. So that's in a nutshell what a GSLB would do. So if you've got a federated system like this where you've got connectivity between these three clusters, and the GSLB needs connectivity to each of the clusters just for health checks, so that it can tell whether it should still be advertising that cluster as a DNS endpoint. And of course, you don't have to use GSLB. You can replace that with a traditional load balancer, in which case your traffic will come into the zone on the top, and from the load balancer be shuttled into the clusters below. The advantage of using a GSLB here is that you don't actually need to funnel all of your traffic through the zone through the cluster on top. You can just tell the client which cluster to use, and the cluster will go directly to the and the client will just go directly to the cluster that's closest to it. All right, let's talk about keeping track of clouds. So another interesting thing about federation is that once you start having multiple clouds of various kinds and distributed across the place, you start doing some very similar things again and again. And you don't really want to be configuring the same things again and again. You want to make templates or patterns and then deploy these patterns into each of your clusters. And it's to solve this kind of problem that within a single OpenStack cluster you have heat and hot templates. But the question is, what do you do if you're not talking about just one cluster anymore? You're talking about multiple OpenStack clusters, and maybe some of those are not even OpenStack anymore. So it's useful to have a generic templating engine that will let you make these patterns and like a factory, stamp out these patterns, deploy these patterns multiple times in different clusters. So another interesting use case is if you think about disaster recovery. Disaster recovery is a very complicated topic for legitimate reasons, and it's that there are a lot of aspects of making two clouds, either active or active standby replicas of each other. There's of course all the OpenStack or CMS related config that includes all of your Keystone config, that includes your NOAA Neutron configuration. But in addition to that, there's also all of your application data. So including all of these makes the problem pretty complex. And what we've seen is that breaking the problem down into two different pieces actually makes for a more manageable solution. So if you can sync just your CMS configuration across to the other cloud, that's something that a federation manager can deal with and stay sane while doing. As for the application level data, I mean, a lot of people who try to do active replication of clouds try to do replication of the application volumes, and and that you should probably leave to the application itself, because usually applications are set up with databases who have replication built in. You can have them replicate to wherever you want. You can take that out of scope for the cloud federation software itself, and that's what we believe is the right way to go. So after looking at all these constraints, and we have seen some of the OpenStack projects around this. There's OpenStack cascading. There's of course Keystone Federation. There are a bunch of OpenStack concepts around it. But a lot of the approaches to federation being discussed today try to build an OpenStack of OpenStacks, and that's a bit heavy for what we have in mind for federation. The federation manager should really be lightweight. If to do your Keystone token authentication, you're going out into the cloud federation, then you're doing something wrong. That's never going to scale. So the entity that's doing your cloud federation needs to be very minimal. And in fact, what we've seen is that you can just build it as a regular web application. Once you build it as a web application, you can deploy it anywhere. You can deploy it in your public cloud if you want. If you're not comfortable with that, you can deploy it in another private cloud, which isn't even OpenStack. So this is the lightweight model that I was talking about, where to configure your clouds, you talk to the federation manager, and the federation manager is designed so that it has a top and a bottom half. It provides this generic object model at the top, and it can have plugins at the bottom that can translate that generic object model into each of the target CMSs. For example, you can have a plugin for OpenStack or a plugin for AWS. The function of this federation manager would be to persist the configuration, push the configuration to where it needs to go, take care of templating, make sure that all the configurations are in sync and are present where they need to be. And like it says here, the applications, you can leave the task of synchronizing databases to the applications themselves. That makes the problem more manageable. And this talks about disaster recovery, which I already covered, that if one of your clusters goes down, you've already synced all your information across to the other cluster, so it's good to go. That's all I had. Thank you.